Okay, so the automatic analysis, in this case, we assume that we already decided to run our automated analysis, and we assume that our malware is not something that is state-sponsored malware, but it is a you know uh, common one malware that we can find on the internet. So obviously you can submit to VirusTotal. I'm not going to show that, but I'm going to show you guys to malware analysis. It's exactly the another version of Kuko Sandbox. That's what I wanted to show you guys. And here is a good tool for that in Windows environment. It is PE Studio. Sorry. So this is the analysis of Metaparator 1 executable. So what it's doing is whenever you drag and drop a file, it's obvious you can drag and drop a file and analyze that. So what it's doing, it's collecting some of the possible indication that could be an unusual file or might be a malware. So for example, this one, it says Apache Benchmark command line utility. It's just a really common name that you can easily find in a Metaparator file. By default, if you are using MSF Venom, MSF Venom will create a shadow copy of an Apache Benchmark command line utility, and you will see exactly the same thing in a Metaparator. So here is indications. We have 12 indications here out of 23, and it says that authorization function has, there is an authorization function, memory management function, dynamic link library function. So it doesn't mean that it's a malware, but there is a chance, okay? And it contains a hard-coded IP address. That's an indication, right? Why? Why we concerned about finding a hard-coded IP address in an executable file? Why it is something bad? Well, so if I was using an domain name, if you are using a DNS firewall, you can easily block that domain name. So there are a lot of DNS firewalls. They can block a domain name if it is under age of 1 month. Okay, if it is 1 month and younger, then it's going to be probably blocked, which means it's recently registered, which means it might be possible that this is used for a phishing attack or any kind of malware. So that's why the content filter, they usually tend to block, or DNS firewalls, they usually tend to block young domain names. Malware creators know that, tackle. That's why they use a hard-coded IP address in their malware. So even if you have a DNS file, it's not going to work because it has a direct IP connection. That's the thing. That is because it's a kind of pseudonym. And blacklisted string, there are 30. Those are also matched, so we can see them in here. And also virus total score, it says 36 out of 52, 54. So if you see something it says virus total, it's a malware, that means it's a malware. If more than 2 antivirus providers say that it's a malware, that is malware. If say no antivirus say it is malware, then it might be either malware or may not. Okay, it's not possible. It is unknown. Okay, so if you see 0 score on virus total, that means it doesn't mean that it's a innocent file, and I can easily submit a file. It's a malware, but it's out of clean for everything. So we're gonna see that example actually. And there are a lot here. So let's take a look at them here. For example, virus total. When I click on that, I can easily see that it's a Trojan variant. See that? So it's being coded by a lot of malware providers, even Microsoft. So if Microsoft codes something as a malware, that's hopeless. Okay, so let me see. So WinSock libraries actually, these are not actually bad habit, but this means that this thing is going to have an socket communication. It's not usually bad, but it's some of the indication if you have at least a virus total score like that. So this is the Windows API function names that it's going to use. So for example, here create file, create file, right? So those are the things that you should be aware of that. And here's the sleep function. Sleep also an indication of interesting for us because we usually don't want our application to sleep, okay, unless you have a good reason for that, but it's rare. And also preset is also another indication here. And also let me see, I think this one is not ransomware, but if it was a ransomware, you will see a lot of crypto libraries here. Ransomware is usually used the Windows API crypto libraries. So if you see a crypto libraries here, that means it might be a kind of ransomware as well. So in the string section, so we see a lot of free environments, global free. So it's doing some memory manipulation here, and this is uncommon. We usually don't use our memory manipulation by ourselves if we are not writing a C code. Okay, so that's the interesting thing. So here is some mutex, and also so these are the barriers that can be used for the shared object, and it's really uncommon for a normal applications. And let me see, these are not actually, but so for example, kernel 32 DLL, it's not uncommon. So this is also interesting. What is it? Get process address, and okay, yeah. Anyways, so this is a kind of automated analysis of an application, so you can see the virus total result as well. But instead of getting only the virus total result, let's get something like this. The beauty of this tool is it's not actually uploading your malware to the virus total. Instead, it's searching for the hash. That's a good thing because searching hash is usually a good idea to start with, and then you can submit your executable to virus total as well. So this is one thing. The other thing is you can use the URL, which is called malware.com. It's actually pretty straightforward. You can submit your file to here. Let me use again malware.com. Okay, it's an Kuko Sandbox is addition of a analysis. So for example, something is already submitted here. You can take a look at that. Of course, you can log in and submit your request here. So when you run this, it's gonna give you a lot of information. But this time, it's been run on a virtual machine. It's been analyzed by automated tools, and the creator of malwares know that this is already be available for everybody. So. And also the static analysis also here. So it's Apache benchmark foundation, and whenever I see Apache benchmark, I begin to think that this is something might be a metaparameter. So there is only one activity here, and let me see network analysis here. No, only this one. No other HTTP request. One host only, and there's nothing else. No drop file. I think this is clean. There is nothing wrong with this file. Okay, let's find something really bad. Analysis. It's usually slow, but while it is being running, let me show you something. So you guys already heard before the Kuko sandbox. So anyways, let's use the Google Help. Yeah, this is the Kuko sandbox automated malware analysis. This is another implementation of this Kuko sandbox. So we can create exactly the same thing by using Kuko. As I said, this is usually slow or may get an error. So what we can do is, of course, Kuko have a lot of features, but the installation is something really difficult. It says download Kuko. It sounds like if you download and double click on that, it's going to run. No, it's not the case. so let me tell you the truth. So this is how you can install. In order to install, you need to prepare your host, you need to prepare your guest. In order to prepare your host, you need to install a lot of things. And in your guest, you need to install something. So it's pretty complicated, by the way. It's not that easy. But luckily, let's say at the end, you solve these problems and you finally come up with that, you will see something like this. This is my machine, okay? And I have a bunch of tools that can be used for the malware analysis. But remember, if you set up, create a lot of applications here, the malware can easily understand that we are running in a sandbox environment. It doesn't look like a real, application, real environment. Let's not do anything here, and let's, act like a legitimate application. That's really common case. But let's assume that some stupid malware developers, they don't think that we are not going to use any dynamic analysis. So let me first copy this photo executable. It's really executable, by the way. It's really malware. So what I'm going to do is I'm going to copy this in my file first. And what I'm going to do is I'm going to drag this to my PE Studio first. And let's see what kind of results this guy have. And also I'm going to use CFF tool to analyze this thing. Just exactly the same thing that we are doing in our static analysis. So it says Microsoft kept SFX. What does that mean? It's a cabinet file. It's not a real executable. It's a container. It's going to self-extract something, so we need to run this thing in order to see that. So you may be in a position that you're analyzing an self-extract executable. There is no way to see that what is inside without running this executable. This is why you may need to run a dynamic analysis, okay? And probably we will still get the virus total result, because whenever you submit them, even it's a self-extracted executable, antiviruses are running that piece of code and then, analyzing the behavior. So we have a lot of things. We already identified that this is something bad, but let's see how it looks like in a real environment. So let me copy this to here as well. And the biggest mistake that you can do is just double clicking on that. Even if it's a sandbox environment, don't click on that. We need to do it in a controlled way, okay? We will run this executable. You don't have to worry about that, but you gotta get prepared for that. First of all, get your stuff ready. I'm gonna start my process hacker to see which processes are going to execute it here, okay? And also I'm gonna start my Apache DNS here to trick what kind of DNS queries are going to be sent. So these two tools usually good for starting. You can start a lot of things. Of course, you can start process monitoring, Wireshark, TCP, Weave, and all of them. But for now, it's too complicated. Let's start with the easier one. So let me explain the Apache DNS first. Apache DNS is actually a local DNS server. It tricks everything, and it intercepts every single DNS request and change the DNS answer to the IP address that you want to use. So for example, if I use a loopback IP address, the malware is not going to go anywhere. And remember, if there is an embedded IP address, what's going to happen here? It's going to connect, okay? This is why usual malware developers can use an IP address instead of domain name. So luckily, this malware have only the domain name. So what I'm going to do is I'm going to change the replying IP address to 127.0.0.1. But we can change this IP address to our Remnox machine as well. So this is the Remnox. It's a malware analysis and forensic investigation Linux distribution. And I can start the INET sim here. If I run this, it's an internet simulator. We can resolve any services and reply to any services that our piece of application is trying to connect. But unfortunately, I don't know what kind of port it is going to connect. That's why it may not be useful if you are running in the very first time. So that's why I prefer to resolve a loopback IP address for the first time, and then try with the other IP address after I identify the port numbers. Okay, so let's start with this Apache DNS, and let's try something here. So for example, in my command line, I'm gonna ping www.google.com. See, 127. That's good. So that means our DNS request is going to be intercepted, and it's going to be redirected to to loopback. And also, while you guys notice that, so when I click on that, just take a look at the process hacker behind the scene, okay? So when I close that, see that red things, red here. Process hacker give you enough time and saying that, hey guys, somebody's killed this process and it's going to be disappear in 10 seconds. Okay, so you can have enough time to what kind of processes are created and which ones of them are dead. So that is another thing that I'm going to look at it. So if there is new processes created, it's going to be green. Okay. So we know the idea and we know how our application is working. So let's put this here and let me put this here and let me put this one here as well. So this is just a real application, by the way. We found it in a hospital. It came from an email that said that this is something stupid. You show my hospital records in a public way. So it's just shocking, and send it to the one of the secretary, and she click on that picture. It's actually a photo. When you click on that, it just shows you something. So let's click on that and let's run this thing. Okay. I click on the executable, and we have a picture. That's really picture. Okay, we see two pictures. See the behind the scene yellow host, and see that some things are disappearing here. See, did you guys notice that? So these are going, and b.exe is actually disappeared. See that? This is the one that left recently. Okay, so we see that this is something new. And also when I look at to my DNS records, I see that somebody is every second asking for seldom.ddns.net. Dynamic DNS, by the way. You can get a free DNS record for everything. Okay, you don't have to register any domain name. This is something interesting. Okay, and luckily our application is not resolving anything, but I am really worried about this b.exe, what it's going to do, and why it is trying to connect to seldom.ddns.net. And let's take a look at the little bit properties of this application first. And you can choose for the strings. I'm going to search for 10 strings, okay, 10 character strings. It's going to find 3,000 strings. Let's see. Oh man, shouldn't take that much.
Would it make sense to start Wireshark?
Yes, actually that's the next point that we are going to do. But yeah, so let's take a look at something here. Okay, when I look at that, I see that it has a handler that says documents.adobe.flashplayer.exe. That's something interesting. I don't have a flash player exe in my documents folder. Obviously, it came from somewhere else. It is coming from somewhere else. Let's drill down that directory. Here you can see that Adobe and flash.exe. That's interesting. And let's scroll down here and let's see what else we are looking at here. Actually, let me sort that because some of them are really good. Ouch. It may take a lot of time to sort and forget about that. Okay. So these are the things that could be used for some other purposes. Okay, command prompt, and this is nothing. Okay, there are a lot actually. It may take a lot of time to analyze all these strings. So luckily, we have a better tool to analyze. So it's obviously doing something connected to some command and control center. So we need to identify what ports is going to be, what cores are going to be used, and what is this flash player exe, and what else this executable is trying to do. So actually, I can take a look at the handler here. And what I'm going to do is I'm going to look at only for the file handlers. So instead of event, let's take a file handler, field device. That should be a better file handler. Okay, yes, this one. See that there is an application data local temp under temp directory. There is something here. Okay, those are the things that we are going to focus on. But obviously, this is something that takes a lot of time. Let's use a better tool. So what I'm going to do is we need to find these things. We need to find all the created and deleted files. We need to find what kind of port is being connected. So in this case, I'm going to use a little bit advanced tool, and that is going to be my capture bot. Okay, luckily I have a capture snapshot here. So let's go back to our snapshot. Don't save. Okay, this is really normal. Whenever you're analyzing a malware, you can restore your virtual machine maybe 10 times even. That's fine. let's say cancel, and I will paste my thing again here. Microsoft thing. Thanks, Microsoft. Settings and display. Just for there we go. So this is my executable again, but this time I wanted to use CaptureBot. So CaptureBot is a free tool again. It should be in my list. This is actually one of my favorite, and it's not on the list. Wow, I will add that. Promise. Okay. So let me change directory to my, where is it? Under my programs. It's not on my programs. It's on my program files. Yes, right here. Okay, now I have a capturebot.exe, and if I run with help command here, it's not help command, let's say .h. Okay, there we go. So it has a bunch of parameters, but this is the beauty of this thing is it's running behind the scene. It's capturing all the network traffic. It's capturing all the DNS requests. It's capturing all the file accesses, and it's going to give me a nice, text file and also the nice folder that also includes the deleted files as well. So what I'm going to do is I wanted to run this in my machine as a file is going to be the photo dot, let's say, log. Okay, the log file. And also I wanted to copy the old files if it is created or deleted or modified during this execution. And also I wanted to capture the network traffic. Okay, these are the three things. But remember, while doing this, you shouldn't, do a lot of things on this machine. Okay, do only the malware analysis, nothing else. Okay, because if you create noise, you may, mess up your malware analysis. That's why I, make sure that nothing is running other than the malware. Okay, let's run this. By itself, it's going to create a little bit of traffic as well. So if I run this, okay, I get my picture again. I get my picture again. Here, I assume that my executable already run that. Behind the scene, did the communication. Let's use the computer in a regular way. Let's say I am looking for my notepad. So choose an application that those are not going to create a lot of noise. So for example, notepad is a good one. Okay, because it doesn't create any connection. So let's say my name, let's say username Jandan, and my password is my super secret password. Luckily nobody see that, and let's close this, don't save. Okay, I didn't write anything, it was on the memory. I think we get enough capture here. Let's stop this one. And also I need to stop the executable because remember it's still running behind the scene, okay? Let's get rid of this thing because this is our thing. And also we're gonna take a look at another thing. But let's see what kind of files is created by CaptureBot. And here it's on log files. And this is the thing that it does the network communication. Let's see what kind of things exist here. So for example, the DNS, already we know that these are the DNS servers, DNS communication. So no response now because malware is not doing anything. If we were responding anything, probably we will see the connections. That's why you may need to use Apache DNS to redirect it somewhere to see the port. We're gonna do that as well. Okay, this is something meaningful, and let's see the deleted file. That's interesting. Under C, user, Jandan, application data, local. Yes, that's the temp file. Remember these files? So it's being created, and b.exe is right here. And also another one, it's again b.exe. You can analyze them as well. So b.exe, so it's creating itself multiple times. Well, it probably is a kind of extraction. Okay, it is something that I wanted to see as well. and let's see the log files. Okay, so photo.log, and I'm going to use the Notepad++ to analyze this log file. Okay, so photo.exe is created by Explorer. This is where I started up my process. As you can see, guys, this just run the b.exe, and then b.exe photo.exe created b.ex underscore, and here again. So let's see something here. What is that? It's an extraction. It's just tapping on some registries. So here again, exe file, exe, some png file. See that? This is the PNG file that we see. Okay, it just shows a picture. Because it's a photo, it has to show something to you to trick. Okay. All right, so we see something again here. Again, picture. Again, let's see. Let me scroll down a little bit more. Okay, Zone Manager Internet file, so it might be a kind of connection. Okay, pip files, .exe file, .exe, cleanup. So Flash player. So run current version intranet exe. See that? That's an interesting file that I don't have. So flashplayer.exe is also running on my machine, and also auto detects are here. So these are flash player again. Let's scroll down. There's a lot of flash player here, and I am looking for specifically for something because that was interesting. I wanted to see, and I wanted to show you guys. Oh, no. Okay. Oh, okay, yeah, there we go. So b.exe file, there is a DC logs here. That's an interesting one. Let's go to this directory. Okay, let's take a look at this. What is look like? Okay. Okay, there's a DC file. It's a text-based file, and when I open that, see what's here? Keylogger. Start menu, notepad, untitled document, notepad, my name, and started backspace, Jandan, and my super secret password. And then I run for cmd exe. I can jump back to here. So it just takes the the title of the window, and it's also locked here. So it is taking the screenshot. It's taking the logs, key logs, and things like that. So it's a keylogger, kind of keylogger. And that is also available in this log file as well. So this is good for capture bot. You can see that that's what's going on here. Of course, you can drill down all the single details. So it's kind of log file analysis now. I'm not going to drill down every single detail. So that's also written here. And one last thing that I wanted to do is what kind of port is this guy is using? Okay, I wanted to identify, but unfortunately the host is not available now. How can I identify? I can treat that. Okay, so this is my Remnox, and let me see the IP address fconfig. So 192.168.8.173. Okay, let's go back to my previous state, and I wanted to show you the last thing that I wanted to analyze this thing. So restore snapshot. Okay, don't save here. So another thing that I wanted to see is whether it's persistently embedding itself to the startup menu or somewhere else. So let's see that. Wow, we're already, but last one. Let's say cancel. Let's change the settings here. Okay, let me copy this thing again to my virtual machine. Okay, let's do two things together. So in my Apache DNS, I'm going to forward to this 192.168.8.170, which is my Remnox machine. Okay, let's start this one. And the other one that I wanted to do is the autorun. Okay, so autoruns is a system internal suite utility. So this is my virtual machine that has no malware in it, right? I know that this machine is clean, and this is its initial state and its startup look like, okay? So auto runs help you to take a snapshot of all starting things at the startup, and also after the malware, I'm going to run this again and compare the results, okay? So I can identify what is changed. So because in order to be persistent in a machine, there are a lot of ways to do it, and you can track them all by hand. So I'm going to save this in my desktop as, let's say, initial. Okay. Oh, this is it. Let's, create here, and I'm going to start Wireshark here. Let's start this, and I don't need a root just for that. So nobody is creating any kind of traffic now. So if I run my photo exe now, let's see Wireshark. I have to see something, Wireshark. Come on. There we go. Okay. Something is going on behind the scene, and my malware is already run that. So I already identified that it's a flash player or b.exe. So let's kill that and let's see how it is going, because I don't want to hurt my infect my machine anymore. So first of all, we identify that the Remnax machine we resolved, remember, 192.168.8.172, and one of my process is trying to connect with 6650 ports. Okay, this is the port that this malware is trying to connect, and as you can see, guys, so the push ACK request is sent to there, and also reset is coming up because the port is not available. Or okay, get update.php, so it's trying to connect, but it's I think it's process, yeah, process hacker. It's not related to that. This is the thing. This is the myman. It is trying to connect. Okay, that's the one how we can identify the port of an malware by tricking the DNS. As you can see, this time one DNS record only, and it's resolved by this IP address. We identify that it's trying to connect with this port. Okay, and the second thing is in my autorun, let's refresh this thing. Okay. So remember, we already saved for the initial state. Now I'm gonna compare that. What is it? Yeah, compare here. And in my desktop, it says initial. These are three changes. So system.pip file is changed with multiple tracking. Flash player in my current version run, and also HP local machine software Microsoft Windows current version user logon, WinLogon, it's been attached. So it is modifying three places to make itself persistent malware. So this is how you can also identify how this malware is trying to do it. So it's a combination of Wireshark, CaptureBot, Process Hacker, and also Autoron, SPView, and the Apache DNS combination. So I know it's a little bit hard to track, but so this is how we can do the dynamic analysis. Okay, guys. So we can use two tools together to identify that. But remember, if you use that in a virtual machine, it means that it doesn't mean that your malware cannot know that. So let me show you last thing, and then let's close this session. So I have my, this is the file, this is the output, MinGV objects. Let's try. If it's not gonna work, okay, this one work. So it says that some anti-debugger, somewhat tricks, it's analyzing Windows version, the CPU is debugger detection, no debugger using, it's a little bit long list, but okay, see, checking difference between TCP times, it's okay, but here's the thing. VM, it's been detected that it's running on a virtual machine. Another one, hypervisor, it's been traced. It's again detected that it's running on a virtual machine. So malware analysis can use that, and also it can, identify the debuggers as well. So we will see that these techniques can be used in a advanced dynamic analysis. Whenever you see you put a breakpoint somewhere, it can be detected by the malware itself. So you gotta identify that section as well. You gotta get rid of that first. And also mass activity, no mouse activity, you just run, I don't see any mouse activity. That means this is something interesting, because in reality I see some mouse activity. Again, checking some VirtualBox things, so it identified the VirtualBox. And let me see, what else here? Yeah, VMware mouse, VMware HDFS, so which means this is a kind of virtual machine. Whenever it detects it's a virtual machine, it may decide to not to do anything. Actually, this is a challenge. We are trying to make this application run in a virtual machine while the debugger is attached. Okay, so you gotta take down at least 52 different checks in order to run this application to see the results. If you do that, that means that you can convince a malware to run on your machine as well.